Okay, so to find the volume obtained by rotating the region bounded by y equals 2x squared minus x cubed and y equals 0 about the y-axis. Let's draw the graph here. Y equals 2x squared minus x cubed all right. So that's what that looks like. 2x squared minus x cubed. Graph it out looks like that. Y equals 0, of course that's the x-axis, and so I'm rotating that little region right there about the y-axis. Okay, think about that. Didn't tell us which method to use here, but we know a little bit about a couple of methods, this method and shell method. Let's figure out here which way we'd want to go. Well, my contention here is this is going to be a whole lot easier if I draw a typical rectangle. Think about the typical rectangle. It's going to be a whole lot easier to do typical rectangles like that. Why? Because there I'm just going from the x-axis up to the curve. If I do typical rectangles like that, you see a problem? That's going from this side of the curve to that side of the curve. I'd have to figure out what this side of the curve is and what that side of the curve is. And that's going to be hard with that formula to do. So hopefully you're agreeing with my contention here that it's going to be a whole lot better to integrate this, the typical rectangles this way, which means integrate with respect to x. But as far as method goes, which method is that? Well, look at the typical rectangle and the axis of rotation. What are they? Parallel, right? So the typical rectangle and the axis of rotation are parallel. What does that mean? Parallel means shell method, right? Yeah, I need to use shell method here because that's the way I want to do this. Axis of rotation, typical rectangle, parallel. So shell method, integrating with respect to x, shell method. So that's volume equals a to b, 2 pi x times f of x dx. So in this case, let's plug in the actual values. All right, so a to b, well, I just need to figure out, obviously it looks like a is 0 here. Just need to figure out that. We could just do, set these two equal just to make sure. Sometimes it's a little bit off of what you might think. It looks like it is, I don't have my graph, but it looks like it's 2. But you better be sure, because you don't, if you're off a little bit, that throws your whole answer off. So yeah, just set those two equal like we did do. Let's see, factor off an x squared, so it'd be 2. Oh yeah, it's not going to do that. X squared equals 0, that's our, of course our x equals 0, you got that. 2 minus x equals 0, so that's 2 equals x. Yeah, so it was 2. We would have guessed right probably. But it never hurts to check. So it is 0 to 2, okay? All right, then my 2 pi x, all right, yeah, so I've got an extra x, and then multiply that by my function, which is 2x squared minus f of x. Oh, sorry. 2x squared minus x cubed with respect to x dx. Yeah, so on the shell method, we haven't done one yet, but on the shell method, the first step usually you do is go ahead and distribute your x. Maybe not always have to do that, but makes sense here to do that. So that'll be integral 0 to 2 pi times, that'll be 2x cubed minus x to the 4th dx. So now all we have to do is 2 pi times the antiderivative of that. The new power would be x to the 4th. So that'd be 2/4 x to the 4th, which that'll reduce to 1/2 x to the 4th. The antiderivative of that would be 1/5 x to the 5th. And goes from 0 to 2. That's 2 pi times 1/2. 2 to the 4th is 16. Minus 1/5. 2 to the 5th is 32. Then plug in the 0. Most of the time 0 use 0, but try to check. Sometimes they don't. Yeah, that would be 0, and that would be 0. So 0 is going to be 0, so it's what? 8 minus 32/5. 1.6. But it's multiplied by 2, so it's one way you can put it is 3.2 pi. Yeah, they probably don't like that for answers back. That is a fraction. That's 1.6 times 2 is 3.2. Take that to a fraction, 16 fifths. Yeah, they would write that. Take your pick. I'm okay with either one of those. Yes? Good? Okay. All right. Let's do another. Okay, so find the volume of the region obtained by rotating. The region bounded by y equals x squared minus 4x minus 3, and y equals x minus 3 about the y-axis. And the volume obtained by rotating. Region bounded by y equals x squared minus 4x minus 3, and y equals x minus 3 about the y-axis. All right. Let's graph that. Got a parabola and a line. Okay, so the parabola is here. And, oops, that should have been lower. That should be -3. Where it intercepts the y-axis, and y equals x minus 3, and shows it sort of like that, roughly speaking. So I want to take the region bounded by those two and rotate it about the y-axis. Okay, let's start with which way we want to integrate this. Typical rectangle, draw the typical rectangle in here. Yeah, again, my contention is the typical rectangle I want is this way, because that way I'm just going from this one down to this one. If I did the typical rectangle the other way, I'd be going from this one to this one here, so that'd be okay, but down here, I'd run into a typical rectangle would be from here to here. So for one thing, I'd have to do I'd have to break it up there and do 2 separate intervals. And then the other thing, for this interval, I'd have to go from here to here, so I'd have to figure out both sides of that function. So that's a whole big mess. Again, integrate with respect to x is the way to go here. Well, if I want my typical rectangle like that, and the axis of rotation is here, those are parallel. So the rectangle, parallel, axis of rotation, that's shell, okay? Okay. So if it doesn't tell you which method to use, that's kind of what you think about. And then if the x rotation is perpendicular to your typical rectangle, that's this method. Shell's parallel. Perpendicular is disk. Doesn't quite roll at the time, so. All right. But it is shell. Now, the other thing here, okay, so shell is volume equals interval a to b, 2 pi x times f of x dx. Well, the thing about this one is the f of x, that's your height, if you will, the height of, if you go back to when we generated this formula, or talked about how this formula is generated, the f of x was the height of the rectangle. The height of the rectangle here, the way I get that is I have to subtract these, so I have to go this one minus this one. So it's a little bit of an adjustment. I don't know if we have to write a whole nother formula here, but just think of that as the height. So to get the height here, I just have to subtract the two functions. So I do the upper minus the lower. So that's the height. So in this case, the height is upper minus lower. So you just have to subtract those two functions there. All right, so the volume would be a to b. All right, so it looks like obviously one of them, the x value is 0. I've just got to figure out the other intersection x value. So to do that, just set those two equal. Get my x values. So subtract x and add 3. That'll be x squared minus 5x. Those will cancel, so that's that. That's 0. So if you factor out an x, that's x minus 5. So that's x equals 0. X minus 5 equals 0. So it looks like, yeah, they intersect there at x equals 5 and 0. So 0 to 5. 2 pi x. Then, like I said, the height, so we'll go upper minus lower. So the upper one is x minus 3. Minus the lower one is the x squared minus 4x minus 3. That's my interval. So in this case, yeah, let's simplify in the parentheses here first. So that would be x minus 3 minus x squared plus 4x plus 3. So the parentheses will simplify to be minus x squared, put them in order, plus 5x, minus 3 plus 3, those are going to go out. So parentheses simplifies to be minus x squared plus 5x. But then again, this is shell method. So usually shell method, the next step here would be going to distribute the x. So we get 0 to 5, 2 pi times negative x cubed plus 5x squared. Then do the antiderivative. So I have 2 pi times the antiderivative of those, negative 1/4 x to the 4th. 5/3 x to the 3rd, the antiderivative there. From 0 to 5. That's 2 pi times negative 1/4, 5 to the 4th. 5 to the 3rd is 125. So 5 to the 4th is 625. And then 5/3 times 5 cubed would be 125. And then zeros are going to give me zeros, so that's good. Negative 625 over 4, got there, plus 5/3 times 125. That gives me 50.08333, but that one as a fraction is 625 over 12. Some version thereof. And then times the 2 pi, usually, yeah, they'll go ahead and multiply in the 2, that'll cancel that. It'll be 6, so it'll be 625 over 6 pi. I believe is what we'll do there. Okay? The only thing I would mention real quick, we're out of time, is yeah, shell method, if it makes sense, so if we've got this function, and all right, so we've got this function here, and we're rotating it about the x-axis. Well, and we're going from C to D here. So we're rotating this region here about the x-axis. That makes sense that it would be integrate with respect to y. Well, typical rectangle, parallel to the axis of rotation, that's shell method. And so, yeah, this one integrate with respect to y. So the shell method in that case would be volume is integral 2 pi y times f of y dy. I'm going to integrate with respect to y. So change everything to y's, c to d, y equals. So that's that's shell method rotation about the x-axis. Yeah. So do I have time to do one of those?